So we already learned. So here is how we find this multi constant. Besides, we need to consider two because this one is in solid form. So everything that is in solid form we can ignore. That's why we put it. That's why we put it a equal to 1 because it is in solid form. So here is how we determine this multi constant, the Ks, for our reaction or our system. So here is the example of our system. This is an example of system. So the question asks us the Ks. The question asks us the molar constitutivity of PbCl2 or chloride in water. So given the question, indication, the information that we can extract from the question is the Ks for lead chloride is 1.6 or 25 at 25 degrees centigrade. So to answer this question, first what we need to do is we need to form a chemical reaction or chemical equation for our species here. So for example here we have lead chloride. So when it's dissociated in water, of course, this one is ionic compound. So it will be dissociated into Pb2 plus Cl minus. And again, we need to make sure this equation is balanced. That's why for 1 mole of PbCl2, we dissociate become 1 mole of Pb2 plus 2Cl minus. So and then we determine the initial concentration. So for initial concentration, because this one is solid, we can ignore this one. And then this one will be ionic compound Pb2 plus and 2Cl minus. So at initial concentration it will be 0. And what happened is it will change for each PbCl or lead chloride. It will be, this dissociation will be increased. It will be increased to by the factor of 1 and by the factor of 2 because of this one. Okay, so that's why at equilibrium it will reach S and 2S. So this is how we write this information. And we know that for Ks is the question is product of reactant. So what happened here is I already proved how to get this question. And again, so here we need to determine here the question asks about the molar solubility. So to find that one, we need to find the S value for this one. So this one is X, Pb2 plus is S, and 2, and for Cl minus is 2S. But remember we need to put 2 because factor of 2 here. So now we will have 4S power of 3, and we rearrange everything. So weapon, and we will have this divided by 4 square root 3. So the question, so we will get the S is 1.6 times the power of -2 molar or mole. So the molar solubility of PbCl2 in water is 1.6 times the power of -2 molar. So next, let's move to the common end effect. What is common end effect? Common end effect is a principle where equilibrium constants remains unchanged, whereas the individual concentration of species may change, and it is applicable to solubility constant and may be used to assess the effect of the addition of species to solution. So it means that if we have 2 species in a solution, we add more here. For this compound we have Na plus and Cl minus, and for this compound we have Pb2 plus and Cl minus. So ion in common here is Cl minus here. So both of the compound contain chloride ion. So where if we add or we add this ion or iodine to their particular solution, so what happens is the equilibrium will be disturbed and it will shift towards a reactant. So what happens here, for example, if we have sodium chloride add in lead chloride solution, so what happens is this PbCl2 will become even less soluble, and the concentration of lead in the solution will be decreased. So for example, if we have this the constant for calcium fluoride is 3.9 10 power negative 11 at 25 degrees centigrade, what is the molar stability of calcium fluoride in a 0.20 mole solution of sodium fluoride? So what we need to do is, first we need to dissociate the calcium fluoride. So we know that this solid can be dissociated, or this species can be dissociated into Ca2 plus plus 2F minus, and given that the molar solubility of KF2 is 0.2 molar, so this one is our initial concentration of F, because it's given as what the molar solubility. So that's why we do like this, 0.2, and the initial concentration is 0.2 and 0. So we can put it as plus. However, the change because we already have one more, so that's why plus S and plus 2S. So the equilibrium it will be S and 0.2 with the addition of plus 2S. So and then from there we can find the S value. So to find the S value is Ks equal to the concentration of Ca2 plus and also the concentration of F minus of 2, because we have 2 here. So we put everything, we put this value in our equation. So we have x 0.2 plus 2x square. And then here we can assume that this 2s is very, very small. We just can use this value. So that's why we will have x 0.2 power of, so here okay, then what we need to do is, if we solve it, we will get 0.04 s, and then we rearrange, so I can say that 0.04 s, and then what next is we move 0.04 s to here. That's why we get S is 9.8 times 10 power negative 10 molar. So that is how we calculate the molar stability of CF2 in a solution of an AF, so or sodium fluoride. Here the most important thing here in our question, we can ignore here. Here is, we can ignore any amount here, because 2s, the ratio is, it will be 2s the value of 0.2 plus 2s. The value of 2s is approximately to 0. That's why we can ignore it because it's too dilute. We can say that it is too dilute. That's why we just use this value. That's why we have 0.04 s, because we already consider this 2s here is to dilute. And that's all. That's all for this topic. So if you have any problem, any question, please you can get back to me, and I will give you the tutorial for this chapter, and we try to solve a question related to this problem next.